This is a video for homework 6, number 9. So this one we have the accompanying data represent the number of days absent, which is our X, and the final exam score, which is Y, for a sample of college students in a general ed course at a large university. So the first thing we have to do is find the least squares regression line. And they're saying treat the number of absences as the explanatory variable, that's your X, and the final exam score as the response variable, which is your Y. So the first thing we want to do is click on the data, and then we're going to open this in StatCrunch by clicking this little blue box here and clicking open in StatCrunch. Now from there, the least squares regression line is actually really easy to find. We'll go to Stat, then we'll go to Regression, and we'll click Simple Linear. And we're going to choose again number of absences as X and final exam as Y, and press Compute. And here, you're going to get, and you can stretch this a little bit, your final exam score. This is your linear regression right here. And you can also see that this is your slope and your y-intercept right here. So intercept is 88.976364, and slope is negative 0.284 approximately. So they wanted us to round to 3 decimal places for each. So if you go back, you can see they're rounding this to negative 2.844 because the 3 is the third decimal place, but the 6 is next to it, which makes us round up. And then for the intercept, it's 88.976 because there's a 3 next to it, so we keep it the same. And that's how they got that value. Okay, now interpreting the slope and y-intercept, what you're looking for here, remember that the slope is change in y over change in x. Now, usually what that means is it's change in y, so your final exam score, over the change in x, so number of days absent. And quite often when you see a slope like this that's written as a decimal, we pretend that it's over 1. So it means that for every additional absence, every 1 absence, so over 1 think, the student's final exam is going to drop, because this is negative, 2.844 points on average. Now the intercept is the point 0 comma this number. That's what an intercept is. It's always an x value of 0. So the person who misses 0 classes would on average earn 88.976. Now the next they want us to predict the final exam score for a student who misses 5 class periods. So what we're going to do here is we can just go to a regular calculator. Okay, and I'm just going to go to this Google calculator, and we're going to take this equation here, negative 2.844, and we're going to multiply by 5 plus 88.976. So negative 2.844 times 5, is that what it was? Yep, and then plus 88.976, so plus 88.976. And that gets me 74.756. So if a student misses 5 classes, this is what this line is predicting that they'll earn. And that's what they're getting here, except they're rounding to 2 decimal places. Now the residual is the difference between the predicted value and the actual value. So if we go back to the data set, a person who missed 5 classes actually earned a 73.4. And then here we had gotten that they had a 74.756. So you take that, that observed score, which was 73.4, and we're going to subtract our answer. So 73.4, and just click minus my answer, so I'll just type it in again. And that's where they're getting the negative 1.356. So it's just the distance from the observed score to the predicted score. So take your observed, which is the one in the data table, minus the predicted, which was the one we got here. Okay? Now they want to know, is the final exam score above or below average? Well, because this residual is negative, it's below. If it had been positive, it would have been above. Now the next thing we have to do is draw the least square regression on the scatter diagram. So you can actually do a scatter diagram in StatCrunch. So if you go, actually we may even be able to do it here. I'm going to click Edit. And I think that I may be able to graph the, no, it's just going to let me graph the residuals. So we will graph the scatter plot. So Stat, we're going to go to, Graph, then we'll go to Scatter plot, or scatter diagram. And this is our X variable, number of absences, and Y variable would be final exam score. And I believe we're good there, and click Compute. So if you first look here, you first are looking for a graph that goes down from left to right. And it seems like all of them are kind of going down from left to right here. But you'll know exactly which one has, if you look here, this one is going, if this is definitely not the least squares regression line because it doesn't fit the data very well at all. This one is a straight line, again, does not fit the data very well, and it's completely horizontal. This one, they're just going ahead and connecting data points, so therefore that cannot be the least square regression line, so that's why it has to be C. This is what we call the line of best fit. And the last one here, would it be reasonable to use the least squares regression line to predict the final exam score for a student who has missed 15 class periods? Well, the reason that it wouldn't be great to do 15 is because see how our data stopped at 9? That would be what we call extrapolation. And extrapolation is something that we really don't want to do in statistics. We don't want to go too far outside our sample data set in order to go ahead and predict. And 15 is pretty far outside number 9. So that's why they're saying no, because 15 absences is outside the scope of the model. Again, it would be extrapolation. Well, I hope that helps, and if you have any more questions on that, just let me know.